Adding and subtracting rational expressions. Remember that a rational expression is just a fraction with variables in it. And the steps for adding and subtracting them are the same as the steps for adding and subtracting fractions that have just numbers in them. So as you're working through the problems, if you ever feel like you're getting lost in the problem, just think back to, well, how do I work a problem like, let's say, 1/2 plus 2/3. The steps are the same. Step 1 is find the LCD. So on this problem, let me scoot that up just a little bit. Find the LCD. Well, if my denominators are 2 and 3, we know the LCD is 6. Step 2, rewrite each expression as an equivalent expression with the LCD. And so you put that 6 as the new denominator. And to get an equivalent fraction, whatever you have to multiply the bottom by to get that 6, you have to do the same to the top. So on the second fraction, to make 3 become 6, we multiply by 2. We do the same to the top. Look at step 3, combine numerators. So here we would add 3 plus 4 would make 7. And then step 4, keep the same denominator, 6. And step 5, simplify. 7/6 is already in lowest terms, so we do not need to simplify it. So these are the steps. Now it's going to look a little different when we have variables involved, but it's the same concept. So I want to go ahead and start out with examples that already have a common denominator. So we can basically skip steps 1 and 2. So on number 1, we're going to go straight. We've already got our common denominator of 5. So we're going to go straight to step 3 that says combine numerators. Now it's addition, so we would add them. I'm going to go ahead and write it out here. It's going to be 2x plus 8x. And then we keep that common denominator. And those are like terms, so those can combine to be 10x on top. And then we check to see if we can simplify. In this case, we can. Remember, you're allowed to cancel out common factors if you have multiplication. Multiplication is the only operation where you can cancel. And 10 is multiplied by the x. So that allows us to go ahead and say 5 into 5 goes once, 5 into 10 goes twice, which is going to make 2x over 1, which is just 2x. So that's our final answer there. Look at number 2. Again, we already have a common denominator here. So we are ready to combine the numerators. Now this is where you have to be careful. When it's subtraction and there's more than one term in that second numerator, it has to distribute to both of those terms. In fact, you may want to put some parentheses on that second numerator, even though they are not there in the original problem. It's as if they are there. So you might just want to draw them, and that may help. It also may help to write this next step out. So I'm going to combine numerators, but before I combine like terms, I'm just going to write it out. 3x plus 4 minus parentheses x plus 5. If you think about when we learned how to subtract polynomials, the step for subtraction was distribute the minus and then combine like terms. Okay, so let's keep our same denominator. So now we're going to distribute that minus. It'll be a negative x and a negative 5. And you could have done that on this step if you want to go ahead and distribute without writing out the parentheses. Okay, still have our common denominator. Now I'm going to combine like terms. So I've got 3x minus x would be 2x, and 4 minus 5 would be negative 1. And I'm still keeping my common denominator. And then I'm going to check to see, can I simplify this? Well, I have subtraction, which prevents me from just jumping in there and canceling. I would check to see if I can factor that numerator, but it cannot factor, so it cannot simplify. If it could factor, I would need to factor it and then check to see if I have any common factors to divide out. But the main thing I want you to learn from that example is that you have to distribute that minus to all the terms in the second numerator. Let's do one more example that has a common denominator. So here we see both denominators are the same trinomial, and you may be tempted to factor it, but we don't have to factor it at the beginning of the problem since we already have a common denominator. We can go ahead and still go to step 3 that said combine numerators. And this is another one with the minus sign and 2 terms in that second numerator. So I'm going to go ahead and write this. We've got 5x minus 12 in our first numerator. And this time I'm going to go ahead and distribute that minus. So it's going to be a minus 3x and a plus 2 all over our common denominator. Now let's combine like terms on top. We've got 5x minus 3x is 2x, and negative 12 plus 2 would be a negative 10. So at this point, we have subtracted the fractions, and this is the answer. But we want to check to see, can we simplify that answer? So we can't cancel right now. We have to factor first. In order to simplify, we have to factor. So on top, I have a GCF of 2. I'm going to pull that out. And on bottom, I'm going to factor my trinomial. We know it's x and x. We need factors of 15 that add to be 8. Those are going to be 3 and 5. Same signs, both minus. Now we do have a common factor. We've got this x minus 5 that's in common, so we can divide that out. It would just equal 1. So now on the top, I have 2 times 1, which is 2. And on the bottom, just the x minus 3. And that is my final answer. So I'm going to go ahead and stop this video here. If you want to practice the problems that have the common denominator already, you can. And then I'll do a second video to show you examples that do not have a common denominator.